This is the second part of CSE paper solution. Today we will see 20 more questions. I have discussed 20 questions in first part itself. The solution video has 4 parts with 80 questions. I have included some mathematics and some technical questions as well. We will move to the questions. So the first question is about the probability. So it is asking to calculate probability if we have a bag and it is containing the 6 white ball and 4 red ball, and three balls we are drawing from the bag, and we are not replacing it back to the bag, and it is asking what is the probability that the first ball run is white and the second ball is red and third ball is white. So the probability will be like when we will draw 6 ball out of 10, so the probability will be 6 by 10, and when we are not replacing it, so that 10 will become 9. Now the whole remaining ball in the bag is 9, and when we will draw the 4 red ball from that, so it would be probability would be 4 by 9. And now we have 8 remaining balls, so again we it is asking to draw one white ball, so when we will draw the white ball, so probability will be 5 by 8. So when we will multiply it, 6 by 10 into 4 by 9 into 5 by 8, so it would be 1 by 6. So answer is B here. So the second question is about the standard deviation. We have set of elements and its standard deviation is k, and it is asking like when we add a constant number to each term, each element, so what would be the effect on the standard deviation? So it is adding 10 as a constant. So and here the answer will be k only. It won't affect the standard deviation, because if a constant is added to all the term, there won't be any change in the variation and standard deviation also. If 10 is added to all the term of old data, we will get new data, but for new data standard deviation remain the same as k. So here you can see I have added the two screenshots, like I have calculated first 0 to 9 the standard deviation, and also after adding the 10, so there is not any change in the standard deviation. Here you can see it is root under 8.25. So yeah, it will the answer will be a here. So we will move to the next question. Third question is asking for number of injective mapping. So it is asking for number of injective function from A to B. So A has a 4 element and B has a 5 element. So we know the formula of calculating injective function. So if A has n element and B has m element, so it would be mpn, like m permutation n. So the formula will become m factorial by m minus n factorial. So we can keep the number in the formula and we can get the answer. So 5 factorial by 1 factorial it will be, and the number will come, the answer will come as a 120. So C will be the answer here. Fourth question is asking for number of generator in of a cyclic group of order 10. So to calculate the number of generator, we can use a Euler-Taussig function. So Euler-Taussig function says that if n is a prime number, then we can have the number of generator is n minus 1. But if it is not a prime number, then we can calculate the what is the factor and their power. Like if n is a number and p1 is a 1 prime, so p1 power p1 power n1 into p2 power n2. So we can make the factor of the a number and what is their power, and then we can apply the formula as p1 n1 minus p1 n1 minus 1 into p2 n2 minus p2 n2 minus 1. So if here is n is 10, so it is not a prime number, so it would be get divided into 2 into 5. So the formula will be 2 to the power 1 minus 2 to the power 0 into 5 to the power 1 minus 5 to the power 0. So 1 into 4 will be 4. So answer will be C here. The number of generator will be the 4 here. So the fifth question is about the Boolean expression. So we have one Boolean expression, and we need to calculate the minimal sum of product. So minimal sum of product means like it is asking for and or expressions. So it should be minimal one, and the expression is like pq plus p complement qr plus p complement qr complement s. So we can take the common q from all the expression. So it would be, and the expression will become the q and in parenthesis p plus p complement r plus p complement r complement s. So we know the property, like here I have mentioned the two property. So first property is a plus ab equals to a, because when we will take the a as a common, so it would be a as a common, and in the parenthesis it would be 1 plus b. So overall 1 plus b will be 1 only, so overall it will come a. And the second property is like a plus a complement b will be a plus b, because we know that Boolean expression follow the distributive property. So a plus a complement b will be a plus a complement, so it would be 1 and then a plus b, so finally we will get the a plus b only. So similarly here, the from the third line from above, and the p plus p, in the second line p plus p complement r, it would be p plus r, and that p component we can take common, so it would be p plus r complement s. So finally that r plus r complement would be r plus s only. So the final expression will come as a q parenthesis p plus r plus s, and finally we will get the pq plus qr plus qs. So this will be the minimal sum of product, so answer will be a here. So sixth question is about the storing binary tree in an array. So the question is, a scheme of storing binary tree in an array X is as follow. Indexing of X start at 1. So indexing will be start from 1 instead of 0. So normally indexing of array start from the 0 only, but it is saying that it is starting from the 1. And the root is located at x1, and for a node stored at xi, the left child, if any, is stored at x2i, and the right child will be stored at the x2i plus 1. To be able to store any binary tree of n vertices, the minimum size of x should be. So it is saying that to store any binary tree. So this property x2y and x2y plus 1, this property is about of the heap only. So we know that for heap we used to store the heap element in array, and it follow the complete binary tree property. So complete binary tree is like labels, the last label should be fully filled, and the this the it should be left associative. Okay, the all the elements should be stored from the left side only, and the like second last level should be fully filled, and the last level, the all the nodes should be the from the left associative, so it should be filled from the left only. So that why, because we want to fill the array, we don't want to waste the array size. So any memory we don't want to waste it, so that's why we use a complete binary tree. So here it has not mentioned about the complete binary tree, so we can have any type of binary tree. So I have mentioned the three binary tree. One is like balanced one, the first one is balanced one, and the second one is left skewed, and the third one is right skewed. So if it is balanced one, so yeah, so a memory will be not wasted here, and we can store the as per algorithm, it has given xi, and left child will be x2y, and right child will be x2y plus 1. So as per algo here, the memory is not getting wasted, but in the left skewed, one memory is getting wasted for the ABC. Like you can see, on the first index A and second index B, but third is getting wastage. And if we talk about the right skewed binary tree, many memory space will be wastage here. Like here you can see, for the 3, we are using the 7th location. So if we put in the formula, like and the 3 n equals to 3, the d will match to the answer. So d will be the answer here, so it would be 2 to the power n minus 1. So for the n equal to 3, the 7th location we needed to store it, so answer will be d here. Seventh question is asking for time complexity, like it is a recursive algorithm, and it is asking for time complexity, and it is recursively calling the that same function n minus 1, and it is calling 2 times, so n minus 1 and n minus 1, and it is asking for what will be the time complexity here. So we can make one recurrence relation based on the algorithm given. So it would be tn equals to tn minus 1 plus tn minus 1, and t1 would be 1. So for the 1 it would be constant only. So the recurrence relation will become the 2t n minus 1 when we will solve it. So we will get the 2 to the power n, at order of 2 to the power n. So answer will be D here. So I have attached the screenshot here how to solve the and this is reconciliation using the substitution method of the algorithm. So here you can see t n minus 1 would be 2 t n minus 2 and then 2 square t n minus 2 2q t n minus 3 and 2k t n minus k and k will be n minus 1 here. So finally the expression will become 2 n minus 1 t1 equals to 2n minus 1. So it would be order of 2n minus 1. So we will forget the minus 1. It is a constant value, so it would be finally it would be order of 2 to the power n. So here the answer will be D. So the next question is, let the player who play cricket be 12 and the ones who play football is 10 and the those who play only cricket are 6. Then the number of players who play only football. So assuming there is a total of 16 players. So it is asking for the number of players who play only football. So the total number of player has already given like it is 16 and the one who play cricket is 12 and the one who play football is 10 and only play cricket playing players are 6. So we can use the Venn diagram to solve this question. So I have attached one screenshot here. You can see so cricket players are 12 and the football players are 10 and the only who play cricket is 6. So we can remove the 6 from the 12. So 6 will be the one who is playing cricket as well as football and the similarly the 10 is the total number of football playing players. So when we exclude the 6, so only football players will come as a 4. So here the answer will be 4. So answer will be A here. So the ninth question is asking for logically equivalent expression. So we have expression P implication Q implication R and it is asking what will be the logically equivalent expression of it. So we have four options and we need to choose one option among them. So we know that in the left side you can see the solution I have added. So we know that one property like Q implication R is logically equivalent to Q complement plus R. So, so the expression is P implication Q implication R. So first we will solve the Q implication R because the precedence of Q implication R is high because of the it is in the parenthesis. So it will be solved first. So the expression would be P implication Q complement plus R. And the similarly we can get the expression P complement plus Q complement plus R and we can take P complement plus Q as a X complement because we want to convert it in the implication. So we took the value as a X complement equals to P complement plus Q complement and we can solve the X, it would be P and Q. So finally expression we will get P and Q implication R. So here the P will be the answer, so it is matching with the solution, so answer will be B here. Now again we have question of probability. So it is asking for the probability of obtaining at least 2 6 in rolling of a fair die 4 times. So at least 2 means 2, 3 and 4. So either we can have 2 or 3 time or we can have 4 times. So we know that the probability of getting 6 is 1 by 6 and not getting 6 is 5 by 6. So we can use the Bernoulli theorem here, like 4 3 2 and in 4 we are choosing the 2 combination and then for each combination we have the probability of the 1 by 6. So the 1 by 6 power will be 2 and 5 by 6 remaining power will be 2 plus 4c3 we are choosing the 3 and in the 4 and similarly we are updating the power also and 4c4 and the here it would be 1 by 6 to the power 4 and 5 by 6 to the power 0. So overall calculation will come as 19 by 144. So when we will solve this, so just divide it and calculate the fraction part. So it will come as 13.19. So it will be 13.2%. So answer will be A here. So the 11th question is about the disk request and it is asking for what will be the total seek time if we use the closest cylinders next scheduling algorithm. So we have some disk request for the cylinders and like we can see 10, 22, 22, 46, 38 and it is asking for what will be the total seek time and per seek time it is taking 60 millisecond. So seek time is 60 millisecond per cylinder. So when we calculate the like total seek time using the closest cylinder next, so we will first see the whichever the cylinder is the closest to the currently cylinder request. So here you can see 22 is more closer, then 10 is more closer, then 6, and after that 2, and from the 2 it is going to the 38 and then 40. So it is serving in the this order. So when we calculate it, so total would be 60, and it is given that the seek time is 60 millisecond per cylinder. So when we calculate, when we will multiply, so we will get 360 here. So answer would be 360 millisecond. So 12th question is about the matrix, or the like it is asking for the what will be the value of k. So the condition for which the eigenvalue of the matrix are positive is. So like this is the given matrix 2 1 1k, so it is 2 into 2 matrix, and so solve it like suppose lambda 1 and lambda 2 with the eigenvalue of matrix A, and we know that determinant is like 2k minus 1 here, and we know that the determinant is also the multiplication of the eigenvalue. So here lambda and 1 into lambda 2 will be the it will be equals to 2k minus 1, so it will be equals to determinant. So we know that lambda and lambda 2, if they are positive, then lambda 1 into lambda 2 would be greater than 0. So 2k minus 1 should be greater than 0, and when we solve this equation, we will get k should be greater than equals to 1 by 2. So here A is the answer. So the next question is about the network address translation, and it is asking that the box company maintains its own server and it is used to implement net. Which type of net should be used for the web server? So in the static net, like the answer should be a static net here. So in a static net, as a private IP address is translated to the public IP address, and it is used for web hosting. So in a single private IP address is mapped to the single public IP address, and it is used for the web server. And here I have pasted three link, and you can see that clearly in every link it has mentioned that it is generally used for the web hosting, and also it has given the example like for enterprise servers and networking device we can use the static net. So here the answer should be a static net, and the answer is B here. So the next question is about the B plus tree, and the search key is given and it is 12 byte long, and block size is given, it is a 1024 byte, and record pointer is given as a 10, and the block pointer is given as a 8, and it is asking for the maximum number of key that can accommodate in each non-leaf node of the tree. So if we talk about the structure of non-leaf node, so it is like it is asking for internal node. So it is like a block pointer would be there in the both side, and in the between one key will be there. Like if we have m block pointer, so m minus one key would be there. So in a non-leaf node, it contains block pointer and key only, but in leaf node it contains block pointer at the end, one block pointer at the end to point the next block, and with that it also contains the record pointer and key. So so it is asking for internal node. So the block structure is like block pointer and key only. So if we will have the m block pointer, so it will have m minus 1 key. So in formula in the figure you can see m block pointer, if it has m block pointer, so it will have m minus 1 key. So m block pointer and the block pointer size it is 8, and m minus 1 key and key size is 12. So when we will solve it, so m will be less than equals to 51. So the maximum order will be the 51, but it is asking for key and the maximum number of key, so it will be less minus 1 then order. So totally it would be 50. So answer will be 50 here. So answer will be here. 15th question is about the diagonalization of a matrix. So we have a 2 into 2 matrix, and like the element is 4 1 2 3, and it is asking for what will be the diagonalization matrix of that matrix. So Like we will not go into the process, so I have attached the one a screenshot. So it is telling about the process of calculating the diagonal matrix of a matrix. So and so what happens in actually, we will talk about the process, what happens and how easily we can calculate from the given option. So the determinant is the product of eigenvalue, we know, and the process of diagonalization brings the eigenvalue to the main diagonal. So here the eigenvalue is 2 and 5. So here you can see in diagonal matrix the 2 5 is in the main diagonal. So diagonalization is nothing but the process of taking the eigenvalue and just putting it to the main diagonal. So this is called the diagonalization, and neither the determinant or nor the eigenvalue change under the operation performed during the diagonalization. Like here you can see, if you calculate the determinant of 4 and 3, so it would be like 10, and in the D option, if you will calculate, it would be 10. Neither the any option is containing the determinant as 10, so only one option is correct, D. Yeah, so the answer will be D here. So the next question is about the multiplexer. Oh, it is asking for the Boolean expression of the output of multiplexers on below each. Like in right side you can see, and the multiplexer is given and some inputs is also given. So S1 is S0 is control input, and R1 R complement, then again R complement, and R is the input. So like we can calculate the expression. So first for PQ we can have four combination 0 0 0 1 1 0 and 1 1 1. So for 0 0 P complement Q complement, then 0 input will come, so R plus P complement Q, this is 1, so R complement will come, then P and Q complement R complement will come, and then PQR. So this is the actual expression of the multiplex. From the multiplexer the function output we are getting. And now the option is B, the P XOR Q XOR R. So when we solve this P XOR Q XOR R, so we will get the same expression as the multiplexer. So the answer will of this question will be B. So it is P XOR Q XOR R. So the next question is from the networking, like it is asking for matching, like match the options and match the combination. So the P is SMTP. So SMTP is a, and like it is application layer protocol, and the BGP is a network layer protocol used for backing the core routing decision on the network. And yeah, SMTP is used for the email transmission purpose. And TCP is a and like a transport core layer protocol, we all know. And the PPP, like it is a data link layer protocol commonly used in establishing the direct network connection, and the direct network connection. So here we can match the options, like P would be 1 and Q would be 4 and R would be 2 and S would be 3. So option B is correct here. So the next question is from the page replacement algorithm. So it is very commonly asked, and um, it is from the operating system. And the question is like, which of the following page replacement algorithms suffer from Blady anomaly? So we all know it, the FIFO suffer from the Blady anomaly. So option C is the answer here. So the reason behind the Blady anomaly, the FIFO suffer, is that it doesn't follow the stack-based algorithm. So yeah, so that's why the Blady anomaly occur in the FIFO. So answer will be C here. So we have a very good question, and it is also little logical. So uh, we will go through it, and we will try to understand what will be the answer of this. So like we can see here some like one loop is going from I equals to 0 to n, and one loop is going from j equal to 0 to minimum of I and k. K is a actual argument, it is a function, and n and k is actual argument. And if j equals to 0 or j equals to k, Cij would have 1 at the location, and else Cij will have the summation of ci minus 1 and j minus 1 and ci minus 1 and j. So the answer will be dynamic programming here, because we know that what we do in dynamic programming, like we it works by storing the result of a sub problem, so that when their solution are required, they are at the hand and we do not need to recalculate them. And this technique of storing the value of sub problem is called the memoization. So here you can see it is how it is storing, how it is calculating the Cij. It is going backward. Ci minus 1 j minus 1 and plus Ci minus 1 j is going backward, and it is taking the value from there. Directly it is taking the value from there, I minus 1 j minus 1 plus Ci minus 1 j, and because it is taking the value, that's mean it has been already calculated. So the sub problem is already calculated here, and it is calculating the bigger problem from the a smaller problem. So this is the technique related to the dynamic programming. So dynamic programming is mainly an optimization over recursion. Wherever we see a recursion solution that has repeated calls for some inputs, we can optimize it using dynamic programming. And the idea is to simply store the result of sub problem. So Ci minus 1 and j minus 1 has already calculated, and also Ci minus 1 and j already calculated. So it is making summation and just calculating the uh, like uh, uh, bigger problem from the smaller problem. Yeah, so from my perspective, it is a dynamic programming algorithm. Yeah. So this is the last question of the video solution, and it is asking about the optimal number of depth, the stages in the pipeline. So the question is, which of the following is the expression of the optimal number of stages of the of pipeline in pipeline circuit if unpipeline circuit takes t time t and gets cost, logic delay are chd respectively. So yeah, this concept is very good. It is a very good concept. So I will explain what it is actually. We will not go, we will not go in derivation, the formula derivation, but the concept we will concentrate on the concept, what it is talking about. So I will take one simple example. So this concept is related to thrashing. So in thrashing, what was happening? OS want to increase degree of multi-programming, right? To achieve more system performance. But everything has some limit. Every work has some limit. After a certain degree of multi-programming, a point of time when it is increasing the degree of multi-programming, after that the beyond after that the performance get degraded drastically. So after beyond a certain limit, we cannot increase the degree of multi-programming because there will be more number of page fault, and CPU will spend more time in swapping the pages. Similarly, we cannot keep more stages in pipeline. If you are thinking like I will keep thousand spaces, stages, number of stages in pipeline, and in every stage there will be one instruction at a time, at a particular time in every stage one instruction can be there, from the instruction phase to instruction decode, then execution, then memory, and then write back. So in these five stages the five instruction can execute, right? But it is not going to work like that. We cannot keep as many as number of stages we want to keep. So everything has optimal choice of. So the same thing it is asking for, it is asking for the optimal number of stages in the pipeline, what can be. So this expression you are seeing in on the screen, k0 equals to root under tc minus th. So t is total flow through delay of the pipeline, and c is total stage cost, and d is latch delay, and h is latch cost must be considered to achieve the optimal value k0. So this k0 is depend on these four parameter, and this gives the optimal, this expression gives the optimal choice for the number of desired pipeline. We cannot keep as many as pipeline as we want. So that is not, that will not going to work at the end. So 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 everything has limit. So we cannot go beyond that to achieve the system performance. So I hope you understand it. And yeah, I also want to give some more information regarding this question. So yeah, the answer will be a square root tc by dh. Here you can see in the expression it is written. So after a certain number of stage, benefit level will be off, and the performance will start diminishing. And you know that latch delay, what it is called, that latch delay is actually the it has two types, two time, like setup time and hold time. Setup time is like data must stay stable, right, the before clock edge, and data must should be stable after the clock edge. So everything pipeline is also working on the clock edge only, right? From that clock to that clock, what a stage will execute. So the computer system work on cycle, the clock cycle only. So yeah, we are talking about about that only. So so like for higher performance, use more pipeline stages, nothing like that. It can decrease the performance also. So just we will here in the figure you can see this optimal k0 is on the peak. There is a graph, and in the picture you can see it has one peak point. So there it has mentioned performance cost ratio, the y axis it is performance cost ratio, and the x axis is number of stages, and the graph has been made for these two parameter. So there you can see it is increasing through to a certain limit through the peak point, and after that this is decreasing, right? So everything you can use till a certain limit. After that you cannot use. So in the similar way, the optimal number of stages should be there, not as many as stages we want. So the answer of this question will be a square root tc by dh. So I hope you like the session. So if you like the session, then please and like it and share it and subscribe it. Thank you. Thank you everyone.